Okay. So good afternoon, everybody. So last time I started to explain the idea of time multiplexing. So what I said before is we have 7 segments, okay? All of them are connected to port B. Every one of them has a pin for enable and disable. Here, PB0, PB1, PB2, PB3. So if I put here 0, I enable it. If I put 1, disable, okay? So I want to explain today, so it's very obvious if I put just a number here in port B, so, and all of them are enabled, you are going to see the same number on all of them. So you can see 5, 5, 5, 5, 6, 6, 6, 6, okay? For sure, that's useless, right? So now the question is, if I want to display a number, something like 3752 or any other number, how I can do that? What I explained last time, we can use the idea of time multiplexing, okay? And in time multiplexing, as I mentioned last time, the idea is that on port B, I'm gonna put here the code for 5. And then I'm gonna enable 7 segments. The other ones are disabled. That's why you can see 5 here and these ones are off. Then I'm gonna make some delay here. I have to wait for some time. After that, I'm gonna put the code for number 3 on port B, and then this time I'm gonna enable PB1 and disable the other ones. Very simple. If you wanna enable one of them, you have to put 0. If you wanna disable the other ones, you have to put 1s, okay? Same thing, should have some delay here, and then you have to put 2 and enable this one. You put 1, and then you enable this one. By this way, you can see 5, 3, 2, 1. Is that okay? Very important. And then I have to repeat. It's not only one time. You have to go back and repeat. Okay. So the idea here is that although only 7 segment is on at a time, but if you can do it quickly enough, you should see a very stable number, as you will see in the video right now. Okay. So this is what we call, this is a time multiplexing. You understand the idea? If you can do it very quickly, you are gonna see very stable number. So someone can ask me why we need a delay here. You are telling us you have to do it quickly. So why you need a delay? Simply because if I remove this delay, and that's what I want you to do. You have the board, you have the program, you have the delay. Just remove the delay and see what's gonna happen. Just make the delay is long and see what's gonna happen. So if I remove the delay, so the 7 segments are gonna become dim. Why they are dim? Because actually what happened, you put 5 volt and you remove it quickly. You didn't give enough time to the 7 segment to reach to the maximum brightness. That's why you have to keep it for some time. What you can try it. When I tried it, I find maybe 5 milliseconds is enough time, okay? Maybe this is one point about the delay. The other point about the delay, if this delay is long, so now we agree, if this delay is too short, the 7 segments are gonna become dim. If this delay is long, so now you can see flicker. Flicker means you can now start to see it's on and off flicker. That's why you have to be careful here. You should not, the delay here has to be reasonable. Or let me say it in a different way. If you see the 7 segments are dim, that means you have a very short delay. If you see the 7 segment flicker, if you see flicker, that means you have a long delay, okay? So you have to make the delay reasonable, okay? So someone can ask me, why I would make it this way? Why it's too complicated and turn on, off, turn off, and off, and keep repeating? Why you do this way? Because what is the alternate, what's the other choice? What's the alternative? The alternative is, for example, if you don't want to use the time multiplexing, I have to use, so here, I have to use, for every 7 segment, I have to use one port. Okay, if you don't want to make my time multiplexer. So for example, here I'm gonna put the code for 5 to C5. Here I'm gonna put the code for 6 to C6 and so on. For sure, that's not a good idea because we don't have many ports. That's why we always use time multiplexing. Is that okay, guys? So now I'm gonna teach the program we have right now for time multiplexing, how we are gonna do this. Okay, and so as you see here, guys, I want to display this number. I want to display 3, 4, 5, 6. I want to display this number. Okay. That means if you want to display this number, this is the code for 3. This is the code for 4. This is the code for 5. This is the code for 6. And this code has to go to port B, right? Also, as I told you, if you want to, so what's going to happen here, guys, this is one row. So in every iteration here, I'm going to output this one to port P. Also, I have to send this value to port P in order to enable 17 segment. This one is E. So E actually is 1110. So here I'm going to display number 3 on this 7 segment. After that, you can see here it is D. So D is actually 1011 and so on. You got what I'm saying? So that's exactly what's going to happen, guys, right now. So as you see here, I have to make a loop in every iteration. I'm going to send this one to port B, and then I'm going to send this one to port P in order to enable only 17 segment. Is that okay? So that's what I'm going to do right now. So as you see here, guys, in this program, what I did, I created this array, as you see here. This is in every iteration. I'm gonna use 2 numbers in every iteration, where this one has to go to port B, but this one has to go to port P in order to enable only 17 segment. Okay, so let's see how I made the program. The way I made the program is, guys, in the very beginning. Sorry. Okay, so in the very beginning, register X is here. Register X is here. Okay, and in every iteration, I'm gonna take 2 values so that in the next iteration, register X is here and so on. Once I come to the end, I have to come back to the beginning again. Let's see how I made it. For sure, I don't need to talk about configuration. You have to configure port P and port B. You have to make sure this time you have to disable BG1 because I'm not using the LEDs and so on. Okay, so this is the loop. The program is here, as you see here. In the very beginning, register X is pointing here. This is the initialization for register X, and this is the iterations here. Here I have to make 4 iterations here. Okay, so as you see, what's gonna do here in this iteration, guys, I'm gonna take the byte. I'm gonna take the byte pointed by register X, and then I'm gonna send to port B, so that I'm gonna take this value. I'm gonna send this value to port B. Is that okay? Okay, and then after that, I'm gonna increment X so that X come here. Then I'm gonna take next value. I'm gonna send it to port P, as you see here. Is that okay? So this one, the first one is gonna go to port B, this one to port P. Then I have a delay here. I put a delay, then increment X. So every time you use X, you have to increment it so that next time X is here. Okay, guys? So this is in one iteration. In next iteration, I'm gonna repeat the same thing again, but this time I'm gonna take this one, and then X here. Next iteration, I'm gonna take this one, and then X here. I have to continue until, look at this one, I have to compare the value of X. Once the value of X, this is the beginning address, +0, +1, +2, 3, 4, 5, 6, 7. Once it comes to here, +8, so once X equals the beginning address +8, in this time, I'm not gonna loop to here, but I'm gonna loop to here, to reinitialize X. So once I come to the end here, I have to make sure to go to the beginning again. Okay, guys, very easy. So as you see here, in every X here, every iteration, I'm going to take 2 numbers. I'm going to increment X. Once X comes to here, that means I already finished. So I have to go to the beginning again. Okay, guys, any questions? Okay. So how can you do the same thing using C language? Okay, so what I'm going to do here in C language is, as I explained before, we have this function, segment 7 decimal. All what you have to do here, just to give me a number here. For example, I want to display number 7. and tell me which segment, 0 or 1 or 2 or 3, which one, right? And then everything will be done inside this function. So this function is going to do everything as I explained to before. So it's going to convert this number 7 to the code and send it to port B. So here, as you see here, guys, I wanna display this number. Okay, 3, 4, 5, 6. Okay, so what I'm gonna do here, as you see here, I'm gonna make 4 iteration. 4 iteration. 1 iteration for this one, 1 iteration for this one, and so on. 4 iteration. For sure, I don't need to talk about configuration. That's very easy. You need to disable LEDs. You have to enable 7 segment, as you see here. So if you see here, guys, in every iteration, I is equal to 0, I is equal to 1, 2, and so on until 4, right? So in here in the first iteration, so this one is 0 and this one is 0. So what I'm gonna do, I'm gonna get digit at 0, which is number 3. I'm gonna display it on display number 0. Easy, right? And then in next iteration, this one is 1, this one is 1. So I'm gonna get this time, I'm gonna get 4, display it on display number 1. Then I'm gonna take this one here, okay, and then display number 2, and so on. So after 4 iteration, I'm gonna go again to while to make another 4 iterations. In every iteration, I have to wait for 5 milliseconds. Easy, right? Any question, guys? Okay, so let me show you the video before I continue. Where is it? Yeah, display PG. Yeah, multi 7 segment. This one. Yeah, so you can, maybe the camera is not too good, but you can see the number is very stable. 3, 4, 5, 6. Okay, very stable. I think I'm gonna change the delay. So now I used 5 millisecond delay. It was okay. So that's what I want you to do, guys. I want to, when you go home, you play with it. So the delay here was 5 millisecond. I'm gonna change it. For example, I'm gonna make it like a longer delay, I guess. Let's see what I'm gonna do. Instead of 5, I'm gonna make it like, yeah, 100 millisecond. Yeah, so long delay. That's why you are gonna see right now what I told you about flicker. Yeah, look, it's very obvious. You can see the flicker here. Is that okay? Yeah, you can see the flicker. So only one of them is at a time. Okay. So now what I'm gonna explain right now, guys, as I explained before, and this is something very important. It's the same task. One task, you can put it in the main program, or you can put in one of the interrupts, as I explained before. So now I explain, if you want to do the time multiplexing in the main program, how can you do that? I already explained it here. What I'm going to explain right now, if I want to do the same thing, but using RTI, okay? And I have to use RTI because RTI is used if you want to make periodic, actions. And here I'm doing periodic action every one time. So the idea is, and that's what I'm gonna now jump to chapter 4 to show you how I can do the same thing, the same program. I'm gonna do it, but instead of putting it in the main program, this time I'm gonna put it in IRQ. Okay. So the idea is, look here, guys, everything I did right now, okay, everything I did, I'm gonna do it again. However, this one should be done in interrupt number 1. This one should be done in interrupt number 2. This one should be done in interrupt 3. So this one should be done in interrupt 4. And then in interrupt 5, I have to come back to here. Is that okay? And this time, I don't need delay. Because the time out between each 2 interrupts, this is a delay. So here I'm going to have 1 interrupt and then there is a delay. The time out. So this is very important. So when you select the time out, you have to make sure if the time out is not too long, it's not too short, because the delay is the time out. Please, you don't need a delay here. because you are going to have interrupt, and then after a certain time, I'm going to have another interrupt, another interrupt, another interrupt, and so on. Is that okay? That's what I'm going to do right now. Also, so you should understand. That's why I'm explaining this program, and then next to it, I'm explaining the interrupt to understand the difference between them. The first difference is I don't need delay. This is the first difference, because the delay is going to be in the interrupt. Okay, this is the time out of the interrupt. This is number one. Number two, I can't use the program this way. I cannot increment x. Why? Because if you increment x, as I said before, once you return from the interrupt subroutine, x is going to take the initial value. Okay, so I cannot do it this way exactly as is. That is why what I'm going to do right now, I'm going to use a memory location. For example, I'm going to call it count, and always x always is pointing, x is always pointing here. Okay, and then every interrupt, I'm going to add count. So count should be 0, should be 1, should be 2, and so on. You understand what I'm saying? You will see right now, but you should understand now, guys. That's why I'm explaining the program when I put it in the main program, and now I'm going to explain it when it is the interrupt subroutines. Okay, so you should see the difference. There are two main differences. Number one, I don't need a delay anymore. Number two, please don't increment x. Instead, I have to use a memory location. That's exactly what I did here. Yeah, look here, guys. Okay, so same thing. I have to make this table similar to what I did before. It's exactly the same thing. I have to make this table as I did before. Okay, now as I explained to you before, you have to do this one for RGI. You have to do this too for RGI. However, be careful here. Why you have to be careful? Simply because this time I'm not going to use 7F. You remember 7F I used before? Because 7F is you are going to have a flicker, because 7F is going to make 131 millisecond delay. You're going to have a flicker. So that's why I'm going to use a small number here, 10. So I think 10 is going to make a small delay. Okay, please. I'm sure some of you are going to make a mistake and forget and put 7F, because all the time we use 7F. You will see flicker. If there is a flicker, you should know you have to change this number. So this is the time out between each two interrupts. You have, as I said before, in one interrupt, I'm gonna put one. I'm gonna put one number in every interrupt. So that's why the time out, the time between each two interrupts, I have to make sure it's not too short, it's not too long, as I explained before. Okay, guys. Also, here I'm gonna make a memory location. I'm gonna call it count. The idea, as I told you, x is gonna be fixed. X is gonna be fixed, and in every interrupt, I'm gonna get what I'm gonna do. I'm gonna say x plus count, and then increment count, and then x plus count again, and then increment count. X plus count is gonna give me this one. Okay, increment count. So I'm gonna take this one, so that in every interrupt I have to take 2, similar to what I explained before. But again, the difference is that I'm not gonna increment x itself, because x is gonna lose its value. It's going to take the initial value back. That's why I'm using here memory location. It's called count. So count here, when count is equal to 0, I'm going to take this one. When count is equal to 1, I'm going to take this one. 2, 3, 4, 5, 6, 7. Once the count is equal to 8, so I have to return back to 0 again to repeat. That's exactly what I did. So let's see what I did here. As you see here, guys, what I did here. In every interrupt subroutine, x is going to point at the first location. Then I'm going to read count. Then I'm going to read the value at the location x plus a. And a is count. So x plus count. Is that okay? Then I'm going to increment count. Then I'm going to take the location. I'm going to take here from the array. So as I told you in the very beginning, x is here. X plus 0, I'm going to take this one to port B. Increment count. So it's going to be x plus 1. So I'm going to take this one and so on. Okay. So here I'm going to increment. So I'm going to take the 1 at x plus count after I incremented count. Then after that, I'm going to increment the count again for next time. So here in the first iteration, count is equal to 0, 1, and then I'm going to put it at 2. In next iteration should be 2 and 3. Then I'm going to put it here and so on. And as I told you, once count is equal to 8, I'm going to compare count to 8. Once it's equal to 8, so what I have to do, if it is not equal, so I'm done. If it is equal, I have to clear count because after 8, I have to go to 0 again. Okay, guys? So it says exactly. So in one interrupt, I'm going to take this 2. In next interrupt, I'm going to do this 2, then do this 2, and so on. Once I come to here, I have to go back to repeat again. Again, guys, you don't make a delay here because this function is going to be called every 5 milliseconds or every 1 millisecond. It depends on how big is your time out. Any question? Is that okay? You understand why I have to use count here? I cannot just increment x as I did before. Any question, guys? Okay. So now I'm going to move back to chapter 3. Okay. Now I'm going to move to another topic here. I almost finished chapter. Yeah. Okay. So let me explain to you what I'm going to explain right now, guys. I'm going to explain. Okay. So what I'm going to explain right now, I'm going to explain how can you convert binary to decimal, and how can you convert decimal to binary, and why they are important. And okay, I'm going to tell you why. Very simple. As I told you before, guys, microcontroller can only understand binary numbers. Humans love decimal numbers. That's why I need to convert between them. So let's explain what I want to do. Okay, look here, guys. So for example, you have a byte. This byte has the value of 11111111. Okay, so you have this byte. I want to display this number to the user, to a human. Okay, so for sure I'm not going to display this number in binary because humans don't. So this is coming from microcontroller. Microcontroller give me this one, and I want to display it to human. In order to display it to human, it has to be 255. So I have to do some conversion here in order to display 255. That's what we call conversion binary to decimal. So binary to decimal means, guys, I have a binary number coming from microcontroller. Is that okay? And then I want to display this one. As I told you before, in order to display this one, I have to display 255. So the question is, given this one, 1111, how I can get 2 and 5 and 5? How I can do that? Okay. So what I have to do, you have to run a program right now. I'm going to tell you the idea. So given this number, I have to get 2, and then I have to get 5, and then I have to get 5. I'm going to tell you how. So I need to extract these digits from this binary number. Then if you want to display this number on the LCD, you have to convert this one to ASCII by adding 30. You have to convert this one to ASCII by adding 30. You have to convert this one to ASCII by adding 30, and then you have to send them to the LCD. Is that okay? This is how it is. Or if you want to use the 7 segment, so you have to convert the number 2 to the 7 segment code, right? As I explained before, you have to convert this one to 7 segment code and so on. Is that okay, guys? So the first step, that's what I'm going to explain right now. The first step, given a binary number, how can you extract the digits? After that, you can convert. After that, you can convert this digit to ASCII codes if you wanna display them on the LCD, or you need to convert them to the 7 segment code if you want to use the 7 segment. Is that okay, guys? So what I'm going to explain right now, given this one, how I can get the individual one, I'm going to tell you how. Very simple. So all what you have to do, guys, here, If this number is equivalent, this number is equivalent to 255. Is that okay? All what you have to do is, given 255, and I want to extract the 3 digit. So what I'm going to do, I'm going to divide this number by 10. When I divide this number by 10, I'm going to get a quotient, which is 25. And then I'm going to get remainder with each is 5. So I got 1 digit here. So I got this digit, this one from here. Okay. Then I'm going to repeat again. So this quotient, 25, I'm going to divide it by 10. After divided by 10, so I'm going to get 5, and then I'm going to get 2. So 5 and 2. Okay, guys. So you can see here, every time you divide by 10, you are going to get digit, 1 digit. Is that okay? That's how you can do it. After you extract the digits, after that, as I told you, you can send it to the LCD after you convert to ASCII, or you can send to the 7 segment after you convert to 7 segment code. But you have to be careful here, because you are going to get the digit from right to left. It's not left to right. That's how it is. So after you divide by 10, you are going to get the digit right to left. So you have to display them. You have to display them in order to get 255, not 552. Be careful. You understand what I'm saying? Because you are going to get them from right to left. Okay. So that's what we call, you have to convert binary to decimal. Okay. So again, why I need to convert the binary to decimal again? Because microcontroller is going to give you the number in binary, and for human, I have to convert to decimal by dividing by 10. Okay. So I'm gonna show you here. This is the idea. I'm explaining it here. Okay. So as you see here, guys, for example, if you have this number here, if I have this number, when I divide by 10, I'm gonna get this quotient, and then I'm gonna get the remainder, which is this 5. Okay. Then when I do it again, I'm gonna get 4. Then I'm gonna divide the quotient again, I'm gonna get 3. When divide by 10 again, I'm gonna get 2, and then I'm gonna get 1. Is that okay? By the way, the idea is that you have to keep dividing. If you already know how many digits, it would be easy. However, when I have to stop dividing, when the quotient is 0. So once the quotient is 0, that means you're already done. You don't need to divide again. You got all the numbers. For example, if you have a byte, okay, and this byte, for example, it can be up to 3 digits, Okay. If you want to get the 3 digit, okay, so you can divide by 10 as I explained. However, it may be like 005. Okay, if you want to display 005 this way, that's okay. You can get the 3 digit. Okay. However, if you want to get only 5 and you don't want to display the zeros, just want to display 5. So in this case, you don't need to get 3 digit. I'm gonna get only 1 digit, right? So I don't need 3, only 1. So how I can know if I need 1 digit or 2 digit, or I need the 3? Pretty simple. As I told you, every time you divide, once the quotient is not 0, that means you still have more digit to get, right? Once it is 0, so for example, here in this example, when I divide this one by 10, I'm gonna get remainder is equal to 5. Quotient is 0. Once the quotient is 0, it means I'm done. I don't need to divide again. Look what I'm saying. Anyway, so the question is, so in order to do this division, here, divide by 10, get remainder and quotient. So you have to use one of the instruction I taught in assembly language for C. If you want to do something like that in C language, what can you do in C language? Very simple. In C language, if you have integer, for example, I can say integer quotient or integer Q is equal to, for example, 1, 2, 3, 4, 5 divided by 10. So if you do this divide, if you do this one, and you store the result in integer, so you are going to get the quotient. Is that okay? If you want to get the remainder, so you have to use this one. Okay. So here I'm going to say 1, 2, 3, 4, 5 percent 10. So this percent, it should give you the remainder. Is that okay, guys? So again, in C language, if you want to get the quotient, you have to use this operator. But you have to make sure you have to store the result in integer, not float. It has to be integer in order to get the quotient. If you want to get the remainder, you have to use this one. That's how you can do it in C language. Okay. So I just give you a simple program here. Maybe I'm going to go through it quickly. So here in this simple program, as you see, guys, here I have a number stored in register D, and I want to extract the digits, and I want to store them in a memory location. So as I explained, you have to divide by 10. That's what I did. So here I'm going to put number 10 in register X, and the number is already in register D. So I'm going to divide register D by register X, and register X now is 10. So once I do that, the quotient now is in X, the remainder is in D. Be careful here, be careful. Why? Although the remainder is in D, as I explained to you before, register D is two parts, A and B. Although the register in D, actually, the remainder is in D, actually the remainder should be only in A. B is always 0, so just ignore B and just tick. I'm sorry, it's B and E. Okay, just ignore B, A, and get B from here. Why? Because when you divide by 10, I am sure the remainder is going to be less than 10. So the remainder should take a value from 0 to 9. It cannot be more than that. Okay. That is why, although I store the remainder in a word, but actually because I know the value or the number should be from 0 to 9, 1 byte should be enough. Okay. So that's what I did. That's why here I took register B, only B, I just ignored the A and stored it in memory location. After that, I exchange D with X. I exchange it. Why? Because I'm going to divide again by 10. In order to divide by 10, the number you want to divide has to be in G. Okay. So here I got the quotient, which is at X. Now I have to move it to G. So I did exchange. You can do transfer if you want. Okay. So that's what I did. And then I'm going to make another round of division by 10. Okay. Then another round, and so on. Okay. Here in this case, because I wanna extract 5 digits, 5. That's why here I'm gonna divide 4 times, because remember in the last time I'm gonna get 2. I'm gonna get 2 of them in the last time. Okay, I'm gonna get, for example, if it is 25, you divide by 10, so I'm gonna get a quotient of 2, remainder is 5. So I got both of them in last time. Okay, again, if you don't know how many digits you are going to extract, as I told you, you have to keep dividing until the quotient is 0. Once the quotient is 0, that means you don't need, if you keep dividing, you are going to get zeros. You get what I'm saying? So for example, this is a word. If my number is 155 and then 00, why 00? Because it's a word. This word, I'm sorry, there is a 0 here. So for example, okay. Anyway, so if it is, for example, 155, okay, so here what's going to happen here, if you keep dividing, you are going to get 155. Sorry, it's 65 536. This is a maximum, so you can get up to 5 digits. So if you keep dividing, you are going to get a number like this one, 155. If you keep dividing, so what I'm saying, you have to divide until the quotient is 0. Once the quotient is 0, that means you don't need to divide more. So that's exactly. So if I divide this one by 10, so I'm going to get 15 and 5. I'm going to take 15, I'm going to divide it by 10 again. So I'm going to get quotient 5 and then 1. Quotient is 1, remainder is 5. If I take that 1 here, if you divide it again, now the quotient should be 0, and you should not keep dividing again. Unless if you do that, you are going to get zeros. So you don't need to do that. Any questions? Okay. For C language, what I can do in C language, as I have just explained, you can do the quotient, you can get the individual digit and do the conversion by yourself. You can do that. However, in C language, you know, we always try to use functions to make our life easier, and that's what I did. So now we have 2 functions. These functions are doing everything for you. The first function we have here, it's called write integer to LCD. And the other one, we have another one, it's called write long to LCD. All what you have to do, guys, as you see here, I'm going to define a variable integer. This one is integer, this one is long. This variable is storing a number, okay? And all what you have to do, just to put the number here, and that's it. That's it. Everything is going to be done for you. So what's going to happen? Inside this function, number one, this function is going to divide by 10 to extract the digits. This is number one. Number two, this function is going to convert the digits to ASCII code. Number three is going to send them to the LCD. Very interesting. So this function actually is doing a lot of things. A lot of things. It's going to convert the binary to decimal, decimal to ASCII, then write to ASCII the LCD. You got what I'm saying? So you can just use this function. It's going to make everything easy. Okay. By the way, some students didn't like this function before because, as far as I remember, what happened in this function, I think the book 5 locations, 1, 2, 3, 4, 5 location. Even if your number, for example, if your number is 33, so you are going to see on the LCD space 33. Some students, especially if some students didn't like this one. So what the other way you can do it, if you don't want to use this function, the other way, as I have just explained, you can use the remainder, a quotient and remainder in order to extract the digit, and then now you have full control. How can you display them? This is the problem of function. When I teach a function, it's easy. Just send a number to function. The function is going to do everything for you. It's easy, but you don't have much control, right? But if you do everything by yourself, maybe you have more control. Anyway, any questions? Is that okay, guys? Okay. Great. Now I'm going to move to the next one. So now I explain how can you convert the binary to decimal. Is that okay? Sometimes I need to convert the decimal to binary. Why? Why I need something like that? Okay, so now sometimes you need to convert a decimal to binary. For example, if you ask the user, please give me a number. So you are gonna call the keypad, as I explained to you before. The keypad is gonna give you digits. So the keypad, for example, is gonna give you number 2, number 5, number 5. And now, using this decimal, I have to do something in order to get 11111, which is the binary for 255. Again, translator, we are doing translation. Human is going to give you a decimal number like 255, and then you have to convert it to binary. Same thing if give you 128, so you have to convert 128 to 11111. Is that okay, guys? So how can we do that? That's very easy. So the way you have to do it is, for example, if you have 1 and 2 and 8. Okay. So the easy way to do it is, I know if giving this is actually a problem in the second grade or the third grade. Okay. They give the student some digits and ask the student to form the number. So you know this one is in the ones, this one is in the tens, this one is in hundreds. So if you already know how many digits you have, so for example, I know I have 3 digits. So okay, so the way you can do it is, I'm gonna multiply 1 by 100. Then I'm gonna add 2 times 10 plus 8. If you do this calculation, at the end, you are going to get 128. You got it? So I have to multiply every number by its weight and then add everything together. Okay? So that's how, given these digits, that's how I can make 1 0 0 0 0 0. Okay? Okay. Sometimes we can do it in a different way. What we do something, we call it running conversion. Running conversion. Okay, so what do you mean by running conversion? I'm going to tell you what I mean. Okay, what I mean, you are going to ask the user, give me a number. When you are done, hit enter. Give me a number. So the user give me 1. Okay, so I'm going to say now my digit is 1, or my number is 1. Okay. Now, the user, I'm going to ask you, give me another number. The user gives you 2. So what I'm gonna do now, I'm gonna say number should equal number times 10 plus 2. So every time, so now it becomes 12. So this one becomes like a running binary number, running, okay? So now the user is gonna give you 8, okay? So what I'm gonna do, same thing, number should equal number times 10 plus 8, okay? I can now have 128. Once you hit enter, I'm done. So here I can, so I have two ways. Maybe that's easy in many cases. One way, if you already know the number, okay, for example, I have 4 digits, 3 digits, you can multiply every digit by its weight, add everything together. Or you can do something like running convergence. The idea of the running conversion is every time I get a number, I'm gonna multiply by 10 and then add the new number. By the way, you know what you are doing when you multiply by 10? You are doing shifting. You are shifting the number. For example, if the number is 12, when I multiply it by 10, it should be 120. So what happens? I shifted. This one was in the ones, now it is in tens. This one was in tens, now it is in 100. Now after that, I'm gonna add 8. So now it's 128. Okay, now I got another number, for example, 7. So here I'm gonna multiply it by 10. When you multiply it by 10, so it's like you shift it, okay? And then add 7 and so on, okay? That's exactly what you can do. So let's see how I made it here. I think I have a program here I want to teach. Yeah. Okay. So for example, here in this program, as I told you guys, I have here this number. Instead of getting them from the user, it's already in a certain memory location. So what I'm going to do, as you see here, I'm going to get the first number. I'm going to multiply it by 10. Then I'm going to add next number, okay? And then I'm going to multiply everything by 10, okay? And then add next number. Then I'm going to multiply everything by 10 and then add next number and so on. Or the other way, you can just, if you know how many numbers you have, you can just do this operation here. So anyway, that's what I did here actually. So here I put in B, I put in number 10, I do multiplication. So it's just a very easy program. So just here every time you want to add one number, you just multiply everything by 10 and then you add the number and so on. Is that okay? Anyway, any questions? Okay. So now I'm going to show you one applications for this kind of conversion. Here in chapter 4, we have two very interesting programs in chapter 4 here. Okay. Okay. Yeah. So what I want to do here in this program, guys, okay. So here I want to write a program to count from 00 to 99 on the 7th segment, increment the count every time the IRQ is interrupted. Okay. So that means the source of this interrupted can coming from a sensor. So the idea here, guys, we have IRQ. Okay. This IRQ is counting something. It's counting, okay? Number of customers entering a store, number of cars is counting something. And every time, I told you the way usually you do it, we have like infrared this way. Every time you cut the line, and this one is connected to IRQ. Every time you cut the line, you can generate like a falling edge like this one, okay? So IRQ is counting, Is that okay? And then I want to use RTI. I want to use RTI to display the count. So counting is done by IRQ. Every time someone cuts the line, cut this infrared line, that means there is an event. I want to count how many events, and this counting is done by IRQ. This number 1. Is that okay? Number 2, who's going to display? Who's going to do the time multiplexing? I want RTI to do it. So now I want to use RTI to do the time multiplexing of the counting done by IRQ. Is that okay? So that if I'm going to choose a video now, the way it should work, every time I press a button, the count should increment. I increment the count. In reality, instead of using push button, these interrupts can come from a sensor or device or something like that. Okay. So let's see how it works. So now I want to count. I want to do counting. So and then RTI should do the display. Okay. To do the counting, I'm going to explain two different ideas. Both of them are okay. It's up to you. Okay. So in order to count, there are two different ideas. Okay. In the first idea, inside IRQ, I'm gonna use a binary number. I'm gonna call it number, for example, or count, whatever you want to call it. Count, whatever you want to call it. So every time there is an interrupt, I'm gonna increment the count. This number one. Makes sense? So inside the interrupt subroutine, IRQ interrupt subroutine, every time there is an interrupt, I'm gonna increment count. Okay. Now, this one is in binary. I have to convert it to decimal so that the RTI can display it in decimal. Okay. So the way I did it, as I explained right now, I'm gonna divide count by 10. And now after I divide by 10, I'm gonna get a quotient, I'm gonna get a remainder. Here, I'm assuming I'm gonna count the numbers from 00 until 99. So I'm not going to get more than 2 digits. So it's enough to divide by 10 only one time to get the 2 digits. So here I'm going to divide count by 10. I'm going to get a quotient and remainder. I'm going to store the quotient in a memory location. I'm going to store the remainder in a memory location. This one is called digits. This one is called in the location is digits plus 1. So that's exactly what I can do in IRQ. So number one in IRQ, guys, every time IRQ is interrupted, I'm gonna increment the count, and then I have to convert it to decimal, and then RTI has to use these 2 bytes to display them. So this is one idea. I'm gonna show it to you before I show you the other idea. That's exactly what I'm doing here. Look, guys, here. Every time IRQ is interrupted, I'm gonna increment counter. Here I call it number instead of count. That's okay. So here I'm going to increment the count. And I told you I want to count from 00 until 99. After 99, I have to go back to 00 again. And that's what I did. Number is a byte. So this byte can actually take the value from 0 until 255. But I'm telling you in this application, I don't want to count more than 99. That's why after 99, I'm going to go to 00 again. So here, every time I'm going to increment the number, then I'm going to compare number to 99. Then I'm going to see if it is lower than 99, just to come here, do the conversion. Here I'm going to do the conversion, convert the binary to decimal. Is that okay? But if it is not, if it is greater than 99, so I have to clear it. Is that okay? Very easy. So every time I have to increment the number, if number is greater than 99, so I have to clear it. So that after 99, I have to get 00 again. In the conversion here, as you see in the conversion, I have to divide by 10, as I have just told you right now. So here, I'm going to divide by 10. Once you divide by 10, the quotient are going to become in register X. The remainder is going to be in register G. All what I'm going to do after that, remember, yes, the quotient and the remainder are stored in words, but it's enough to be a byte, as I told you because every digit is going to be from 0 to 9, right? So anyway, so after that, there are 2 memory locations. One at digits at the address digit, because this is like an array. The second one at digits plus 1. So here, what I'm going to do, I'm going to store that here. This is the remainder. The remainder has B and A. I'm going to take only B, as you see here. I'm going to store it in this memory location. Then I'm going to do exchange so that the quotient to come here. And then I'm going to take B, store it in this memory location. Any questions? Please look here. So all what I did, guys, number one, every time IRQ is interrupted, I'm going to increment number. Number two, I have to check if this number is more than 99, I have to make 00 because after 99, it has to go to 00. Number three, I have to convert the binary to decimal. So now always we have two memory locations. Every one of them is a byte. One memory location at the location digits, the other one at the memory at the address digits +1. Is that okay? Now RTI has to display them on the 7 segment. Okay, so again, IRQ is gonna store 2 digits here, 2 digits from 0 to 9 here. This is all what IRQ has to do. RTI is gonna take this digit, display them. How? That's what I'm gonna explain right now. Very simple. In one interrupt, I have to take this one, display it on 17 segment. Next interrupt, I have to take this one. Next interrupt, I have to take this one. You got what I'm saying? So every interrupt, I'm gonna work because this is time multiplexing. Because now I have only 2 digits. I don't have 4 digits, only 2 digits. So one interrupt, I'm gonna take one. Next interrupt, I'm here. Next interrupt, I'm here. Next interrupt here. Next interrupt at here. That's it. Okay, guys, very simple. So I have 2 memory location. IRQ is gonna increment and stores the numbers here. RTI is gonna display these 2 numbers. Let's see how RTI is made. So look here in RTI. In order to display these 2, I told you we have 2 numbers. This case, I define them here. So if you see here, they are defined here 2 memory location. Okay. Also, I need the conversion here. Yeah, for sure, because if I get any digit, I have to convert to the 7 segment code. So if I have number 0, so I have to get this one. If I have number 1, I have to get this one because this is a code for 1. If I have 9, I have to take this one, and so on. Is that okay? Same thing for the enable. For the enable, we have these 2. Okay, guys. So let me say again. So now, what's gonna happen right now? I'm gonna make a variable. I'm gonna call count. Count should have always a number, either 0, 1, and then 0, 1, 0, 1. In one interrupt 0, then next interrupt 1. Then I'm gonna make it 0, 1, 0, 1, 0, 1. Why you make this way? Because in one interrupt, I'm gonna add 0 to this one. Okay, in order to get this one. Next interrupt, I'm gonna add 1 to the beginning address to get this one. So that one interrupt, I'm gonna get this one. Next interrupt, I'm gonna do this one. Is that okay? Also, same thing for digits here. We have digits and digits +1. So if I put x is equal to digits. Okay, plus count. So one time here, one time here, one time here, one time here. Is that okay? So let's make it simple. What I'm saying, guys, is that here I have 2 values here, as you see here, 2 values. Also here I have 2 digits. Very simple. One interrupt, I have to take these 2. Next interrupt, I have to take these 2. How I can do that? Very simple. Count, when count is equal to 0, I'm gonna take the beginning address plus count. So it's gonna give you this one, it's gonna give you this one. Then beginning address plus count after you increment the count to 1. Once count is 1, go to 0 again. So the count should be 0, 1, 0, 1, 0, 1, and so on. Okay. So anyway, I'm gonna show how I made it here. Look here, guys. Yeah. Yeah, here. Look here, guys. In the very beginning, guys, as you see here, x. I'm gonna say here, x is pointing at a display tip, which is this one here. This one, x is here. Okay, guys. After I read the digit, so x is here. Okay. After I read now I have 2 digits. Is that okay? So number 1, I have to get a digit, and then in order to get the 7 segment code for this digit, I'm gonna add this digit to x. Make sense? I have to add this digit to x because this digit should be a value from 0 to 9. So 0 plus x is gonna be here. 1 plus x is here. 2, 3, and so on. So this is how can you convert? That's what I did. So oops. Sorry. Yeah. So number 1, x is pointing at the first location. Now I need to get a digit. Which digit I have to get? So what's going to happen? Y, I'm going to use y. Y is pointing here. And then I'm going to add y plus count. Okay, in one iteration, count is 0 in order to get this digit. Next iteration, count is 1 in order to get this 1. Then count is 0, count is 1, count is 0, count is 1. Should be continuous this way. So what I'm gonna do, number one, y is here, and then I'm gonna read count. I'm gonna put count in B. Then I'm gonna add, this one is gonna add y equal y plus p. Is that okay? So I'm gonna add the beginning address plus count. Okay. So if count is 0, so I'm gonna get the address of this digit. If count is 1, I'm gonna get the address of this digit. So that in one interrupt I'm here, in next interrupt I'm here, next interrupt here, next interrupt here, and so on. Okay. So now y is storing the address of the digit I have to display, right? So I have to read the digit, as you see here. I have to read the digit. I'm gonna put it in register A. So y is storing the address of the digit. A is storing the value of the digit. So for example, if this digit is 5, okay, so now 5 is stored in register A, right? And then after that, I have to get the safe in segment code for this digit. How can you get it? X plus A. Put it in register B. Okay. Make it simple. I'm gonna make it simple right now. Look here, guys. X is here. All what I'm gonna do, I'm gonna add the digit. That's it. I'm gonna add the digit. If the value of the digit is 0, I'm gonna get this one. If it is 1, I'm gonna get this one. If 2, I'm gonna get this one. That's it. How can you do that? I'm gonna say A comma X. X is pointing at the first location. A is storing the digit, which is a value from 0 to 9, in order to get one of these digits. Is that okay? That's exactly what I did here. So what I did, I'm gonna take this one to send to port B. So now I finished half of the work. What do you mean by half of the work? Port B. Now I have to work on port P. As I told you, what I'm gonna do, guys, in one interrupt, I'm gonna take this one to port P. In another interrupt, I'm gonna take this one to port B, and then I'm gonna keep repeating it. How can you do that? All what I'm gonna do, X is pointing here, then plus count. That's it. So then I'm gonna take this value. That's exactly what I did. Look here. So after that, I'm gonna read count, put it in A, and then I'm gonna say A comma X. So X is pointing at the first location plus A. A is count, which take a value 0 or 1, 0, 1, 0, 1. So I'm gonna take this one, send to port P. Now I am done. I finished port B, I finished port P. Okay. Now I have to check count. Then after that, I'm gonna increment the count. And if count is 2, if count is not 2, I am done. If not, make it 0. So I am forcing count. I'm forcing count to be 0 or 1, 0 or 1, 0, 1, 0, 1, 0, 1. Why? In order for one interrupt, I want to take one digit. Next interrupt, I have to take next digit. In one interrupt, I have to take one value here. Next interrupt, I have to take another value. Is that okay, guys? Okay. So let me ask you a question. This program is only for 2 digits. What if I wanna display 3 or 4 digits? What I can do? Let's talk about 3 digits. What would I change here? Number one, you have this one should be 3 instead of 2. 3 digits. Number 2, you have to add another value here. This number 2. Number 3, count should have value 0, 1, 2, and then 0, 1, 2, 0, 1, 2. This is the pattern of count. So that when count is 0, I'm gonna get this one. Count is 1 here, 2 is here. Same thing for digit, because now you have 3 digits. Is that okay? So that's why you have to modify this one here. Instead of, I'm not gonna clear count when it is 2. I'm gonna clear it when it is 3. Okay? Because I need 0, 1, 2. Is that okay? Also, you have to do some change also here, guys. Here you have to do some change, because here I divided only one time by 10 in order to extract 2 digits. Now you have to divide 2 times in order to extract 3 digits. 3 digits. For example, if you have something like 27 or 251. So here you have to divide by 10 one time in order to get 1. Remainder is 1. And now we have 25. Now I have to divide again 25 by 10 in order to get 2 and 5. Okay, you have to modify this one again. Any questions? I'm going to choose a video now of this one. Look here, guys. Every time I press the button, I trigger IRQ interrupt. When I trigger IRQ interrupt, I increment the number, as you see here. Okay. Okay. So what I want to teach after that, guys, I told you here for IRQ. For IRQ. All what I have to do here in IRQ, guys, here in IRQ, all what I have to do, every time IRQ is interrupted, I have to increment the count. I have to increment the count, and then I have to convert binary to decimal in order to store the 2-digit in two memory location, as I did here. Is that okay? That's what I did. I did it this way. So the way I did it here, this is one way. I did it here. I increment a binary number. This number can take a value from 0 until 255, but I'm gonna force it to be no more than 99, as I did here. Is that okay? And then I'm gonna divide by 10 to get the digit. This is one way. I'm gonna teach another way. Okay, both ways are okay. Whatever you like, it's okay. So what I'm gonna do right now, guys, I have, as I explained, I have 2 digits. I have one at the location digits. I have another one at the location digits plus 1. Is that okay? This one is a byte. This one is a byte. So actually, this one can take a value from 0 to 255, but I'm not gonna do that. I'm gonna force this one to take value no more than from 0 to 9, because that's a digit. Okay. So what I'm gonna do right now, for example, guys, if you have, for example, 22. Okay, I'm not going to increment it this way. I'm teaching another approach. And this approach, what I'm going to do, I'm going to increment the list. I'm going to increment this one. Okay, for example, I'm going to keep these numbers in the format of decimal numbers. Is that okay? So when I increment, for example, I'm going to increment. So now it's 23. Okay, that's it. So I'm going to increment the first one. If the first one, and then 24, 25, and so on, that's it. So every time I increment. Now, if this one is 29, and I increment the first one, is going to be 210. Because this, again, remember, everyone is a byte. Okay, so after 9 is going to be 10. What I'm going to do right now, I'm going to check. If this one is 10, and 10 is not allowed, so I'm going to make it this one 0 and increment next one. You got what I'm saying? So again, what I'm gonna do, I'm gonna have 2 bytes. But when I increment the number, I'm gonna increment in a way that keeps them correct decimal numbers. You got what I'm saying? So what I did here I increment a binary number, and then I divide by 10 to convert it to decimal. Now I'm gonna increment in a different way in order to keep the numbers in the format of digital numbers. But I'm going to show you how I made it, as I have just explained right now. So as you see here, guys, I got the first number, as you see here. Then I'm going to increment the first digit. So again, as I told you, for example, if I have 28, okay, all what I'm going to do, I'm going to increment the first one, 29. Then I'm going to check, is this one less than 10? Yes, you are done, right? Then increment again. So now it is 2 and 10. Is this one is more than 9? It's yes. So now this one has to be 0, and I have to increment the next one. Okay. So that's what I'm going to do right now. I'm going to show how I made it. So now X is pointing at the first digit. I'm going to increment the first digit with the least significant one here. I'm going to increment it. Okay. Then I'm going to compare it to 10. If it is less than 10, I'm done. Just leave. I'm done. Okay. So actually I have 2 bytes. But the format, I'm going to keep the format of the 2 bytes as binary as decimal numbers. right? That's why it's already converted. I don't need to convert, okay? Otherwise, if it is equal to 10, so for example, as I did here, when you increment now it is 10, what I have to do, number one, I have to clear this one and I have to increment is the second digit. That's what I did, increment the second digit. Is that okay? After you increment the second digit, what happens when the second, for example, after 90, for example, after 90, for example, 99, for example, okay? So when you, this one is going to be 10, no, it's not allowed, so it's going to be 0, then I'm going to increment the other one. Now the other one is 10. It's not allowed because every digit should be in decimal format. Every digit should be from 0 to 9. So what I'm going to do right now, after 99, it has to be 0, 0. So here, I have to check if this one is 10. If this one is 10, I'm going to make it 0. So that after 99, it has to be 0, 0. That's what I did here. So now, after I increment the second digit, now I'm going to check if this second digit compared to 10. If it is less than 10, okay, I'm done. I'm totally fine. I'm happy. Otherwise, you have to clear it. So that after 0, 0, anyway, it's just whatever you like. So I taught two approaches. Whatever you think it's easy for you, it's okay. So now here I'm using 2 bytes. Everyone can take a value from 0 to 55. However, I'm gonna force everyone, or I'm gonna force the format of the 2 digits to be like decimal numbers. Okay, guys, any questions? Okay, so I'm gonna also teach now a very interesting program. It's just I'm gonna just twist this program a little bit. I'm gonna twist it. Okay, so what I did so far, guys, I explained number one how I can use IRQ to counting. So what I did right now, guys, I explained number one, how can you count? And then after that, how can you convert to decimal? That's what I did. Number two, how can you do time multiplexing to display the 2 digits? Is that okay? Okay, that's what I did right now. Okay. Now I want to do a little bit twist. What's the twist you want to do? Okay, number one, I want the count to be done by RTI. So now every 1 second. So now I want to convert to timer. Instead of counter, it's going to become a timer right now. Every 1 second, I want to increment. So what I did right now, guys, I was counting events. Every time I press a button, I'm going to trigger IRQ interrupt in order to increment a count. What I'm going to do right now is I want the counting to be done by RTI every 1 second. So I'm going to make it like a timer. You can see 0, 0 for 1 second, and then 1, then 2, timer. Is that okay? So all what I'm gonna do right now, exactly same thing, but I'm gonna shuffle. I'm gonna shuffle things. So this part of the code, I'm gonna remove it from IRQ. I'm gonna put it in RTI. So every 1 second you have to increment, and this is how can you increment. I already explained it here. Is that okay? This is number one. Number two, who's gonna take care of time multiplexing if you use RTI? I wanna put the time multiplexing in the main program. It's number two. Number three, I wanna use IRQ as well in order to enable or disable counting. To pause, you can suspend or you can continue counting. Pause or continue counting. Let me say it again as we see right now. So what I'm gonna do right now, guys, I'm not gonna teach anything new. I'm gonna just shuffle things. Time here in this program, time multiplexing is done by RTI. I'm going to remove it from RTI. I'm going to put it in the main program. Is that okay? Counting is done by IRQ. I'm going to take it from IRQ. I'm going to send it to RTI in order to count every 1 second. Is that okay? And then I'm going to use IRQ to enable or disable counting. Okay. So let me show, before I show the program, let me show the video how it looks like to better understand it. This is for 1 digit. Here we are using 2 digit, counting 2 digit. Yeah. Look here, guys. 29, 30. It's counting. Who's doing every 1 second? I'm going to increment it every 1 second. Who's doing this one? RTI. RTI is doing it. Okay. Now, when I press the button for IRQ, I trigger IRQ, I'm gonna suspend. I'm gonna stop it. When I press, it's gonna continue. How I can do that? Very simple. In IRQ, what I'm gonna write in IRQ, if RTI is enabled, disabled. If it is disabled, enabled. That's it. How can you do that? Just one bit, the enable bit. I'm gonna XOR, I'm gonna flip this enable bit. That's it. Okay. So let's see how we can do it. Again, you will see right now, there is no, I'm not gonna teach new code. Already what I did right now, but I'm gonna just shuffle it. So the code I wrote in IRQ, I'm gonna put it in RTI. The code RTI, I'm gonna put it in the main program. Okay. So that's what I'm gonna do right now. So here, let's take one by one. Let's take the easy one first. So this is the first easy one. Here. Okay, so here let's look at IRQ. IRQ, as you see here, guys. In IRQ, I'm gonna flip one bit to enable or disable RTI. Just to flip one bit. That's it. Is that okay? One more thing. This is for counting in RTI, as we did before. Every 8 interrupts is gonna be 1 second. So here I'm gonna count interrupts. So if it is every 8 interrupts, I'm gonna increment. This is the code I have just explained right now. This is how can you increment. So I'm gonna increment 1 digit. So you can use the other idea, the other approach I taught. So whatever. So here this part is gonna be executed every 1 second. This is how can you increment. This is the same code I just explained right now. Okay. So, but this part is going to be executed every 1 second because I'm going to count for 8 interrupts. If it is less than 8, I'm going to leave. Less than 8, every 8, I'm going to come here. 8 interrupts makes 1 second. Now, this is the code. It's the same code I taught right now for display to display. Okay, it's exactly the same code, but I just removed it, and still we have count. Still the same code. Okay, I just put it in the main program so that the main program can do time multiplexing. RTI can do the counting. IRQ can enable or disable or compose it. Any questions? Is that okay? Okay, guys. Okay. Let's have one more program. We can do it quickly here. So here in this program, I want to control the traffic light of intersection. For example, you have intersection this way. You have intersection this way, and I wanna control the traffic light. So every way, as you know, there are 3 lights: green, blue, green, yellow, red. Right. So what's gonna happen right now? As you see here, I want to do something like that. For one street, if one street is green, the other one should be red for 5 seconds. Then after 5 seconds, this green has to move to yellow and red has to continue red. This is only for 1 second. And then after 1 second, yellow should be red so that now both of them are red. Then after 1 second, the red should be green, right? To open so that the cars in this street, this is traffic light, right? And then after 5 seconds, this green should become yellow. And then after that, both of them are red, and then you have to repeat again. Okay, guys. So now, as you see, we have states. If you are in a state 0, so it has to be green, red, and this should continue for 5 seconds. If it is state 1, so yellow, red should continue for 1 second, and so on. Okay. So what I'm going to do here, guys, I'm going to use the LEDs to simulate this green and yellow. So the first 3 LEDs are going to be used for one street. So green, yellow, red, green, yellow, red for the LEDs. So I'm going to use 6 LEDs right now. Okay. So the idea is that what I'm going to do, I'm going to explain in C language. So as you see here, guys, I'm going to create 2 arrays. 2 arrays. One array for each state. I told you I have states here. Okay. If I'm state 0, so it has to be this way, right? And then it has to continue for 5 seconds. So I'm going to create 2 arrays. One array for the value I have to put it in port B on the LEDs here. What value I have to, which one I have to turn on and which one I have to turn off. Okay. So as you see here, guys, if you are in state 0, this is the value I have to put it in port P in order to turn one color So if you put this way, you can see here red and the green. So this one red and the green for one street. Okay, so this is state 0. For state 1, so now this one is red, this one is yellow, and so on. So every state, if I'm state 0, very simple. All what I'm gonna do, I'm gonna take this one, send to port B. If I'm state 1, send to port B, and so on. So I have 6 states. Okay, same thing for the delay. So how can you control the delay? Okay, so if in state 1, as I told you, state 0, it has to continue for 5 seconds. State 1 should be 1 second, and so on. How can you control it? All what I'm gonna do here, in state 0, I'm gonna make another array. I call it delay. If I'm in state 0, so I have to count for 488 interrupts before I move to the next state. If I'm in state 0, I have to count for 488 interrupts before I move to the next one. Why it is 488? Because I'm assuming here every interrupt is 10 milliseconds. So that's how can you make 5 seconds. Okay. So if you are in state 0, again, look guys, that's very easy. If I'm in state 0, I have to take this one, send to port B. That's easy. If I'm in state 0, this one will be my counter. So I have to count 488 interrupts before I move to the next state. Is that okay? Next, if you are in this state, you have to wait 98, which make 1 second. This one you have to wait. You have to count for 98 interrupts. Okay. So I'm going to show how I made it. It's using RTI. So if you look here at RTI, guys, what I did here, we have a variable. This variable is called IX. I define it here. So we have IX. So IX should tell you what is the state. So IX actually should be 0, 1, 2 until 6. And after 6 has to go to 0 again, because we have 6 states. Sorry, from 0 to 5, as you see here. So this is IX. So IX should be 0, then it should be 1, 2 until 5. After 5 has to go to 0 again, right? If you are in 0, so all what I'm going to do, very easy. The value of IX, I'm going to come here, take this value, put it there. The value of IX, I'm going to take whatever here, and this should be my counter to count how many interrupts before I move to the next state. Okay, so let's see how I made it. Look here, guys. Number 1, I'm gonna read. This is IX. I'm gonna read the value from the array. Then I'm gonna send to port B, as you see here. So I'm gonna read the value IX from this array here. Okay, this number. Number 2, for the delay, I'm gonna read this one. Put this one in G time. The delay, and then as you see here, and then I'm gonna increment ix. Okay. Then if ix equal to 6, so now I have to make it 0 again, because ix should be 0 to 5. After 5, it should not be 6, it should be 0 again. So that after I finish this 5 and this 5, come back again. Okay. So what's gonna happen now? Because I'm going to store some value in D time, this variable, for example, for each, for example, what's going to happen in next interrupt, I'm going to decrement it. Is that 0? No, it's not 0. Just leave. So is this exactly what's going to happen? So if I am in state 0, I'm going to take this one. I'm going to put it in a location in a variable. I'm going to call it T time. So that I'm going to move to the next state after this number of interrupts. How you made it, as you see here. Every interrupt, I'm going to decrement the time. If it is equal to 0, now this is the time to change it to the next state. If it is not, so you have to wait until it is 0. So that's why if I put here 98, so the next change is going to be after 1 second. If I put here 488, is that 488 or? Yeah, 488. So the next change is going to be, because I'm here we do the change in this part. Is that okay, guys? So as you see here, guys, very simple. All what we have to do here in every interrupt, I'm going to see if the T time is equal to 0 or not. If it is equal to 0, I'm gonna get this value here from here. I'm gonna take one value from these ones here. I'm gonna put it to port B. Okay, in order to turn one light on and another light off, and then I'm going to take the delay, put it in D time, and then I'm going to move to the next state. I have to make sure if you already, if the next state is 6, you have to make it 0, right? Then what's going to happen next? once you put here, this is maybe the tricky part. Once I put a number here like 98, that means the next change should be after 98 interrupts, which is 1 second, because every time I decrement this one. Any questions? Oops. Any questions? Do you want me to say it again? So again, you should understand this part. We have states. For every state, there is some value I have to send to port B, and there is a certain delay for every state. So this is the value I have to send. This is state 0, state 1, state 2, state 3, and so on. And this is the value. This is how many interrupts I should have before I move to the delay. This is a delay, right? So every time I'm going to take this value, put it to port B. Also, I'm going to take this value from delay. I'm going to put it in D time, so that next change, or when it changes, okay, it has to be after this time. Is that okay, guys? Any questions? So let's see. I'm gonna maybe just in 1 second, I want to choose a video of this one as a traffic controller. You see right now. I'm sorry, it's just I took more time today, but yeah, as you see here, guys, in the very beginning, we said, I don't remember, but let me see which one is. Yeah, I think this is red. I'm trying to figure it out. Anyway, let's see. So here, which one is red? We said, yeah, here. Yeah, green, yellow, red, green, yellow, red. Okay, so let's do it again. Look here. So this one, these 3 LEDs for one street, these 3 LEDs for another street. So it's green. This street is green. This one is red. For how long? For 5 seconds. Green, one street is green. This 3 for one street. This 3 for another street. And now this one is yellow for 1 second. Now red and red. Now this street is green and this one is red for 5 seconds. After 5 seconds, it's gonna be yellow. This is street yellow, and this one is still red and red. And then now it is green and red. Very interesting. I love it. Okay. Any question, guys? Is that it's not difficult if you think about it? Just I have to erase, and I have a variable for the state. Okay, all what I'm gonna do, I'm gonna take one value here to port B. I'm gonna take one value here. I'm gonna put it in D time, and then next change after is gonna be after D time. This is how I created a delay, right? So after a number of interrupts, I'm gonna move to the next state. Any questions? Okay, thanks very much.